All right, so I did post videos on both lipids and proteins, but I understand there were some audio issues, so I'm going to repost 2 new videos for the lipids and the proteins. I got a new microphone in the process, and obviously I didn't know how to work it properly, so I think I figured it out. We're going to go through lipids and proteins again. And actually, I'm glad I had the opportunity to, because one of our students asked, how do I tell the difference between lipids and carbohydrates? So carbohydrates we've dealt with. We know they're made up of carbon, hydrogen, and oxygen. And I think maybe some confusion comes here. Lipids are also made up of carbon, hydrogen, and oxygen. But a couple things to keep in mind with lipids versus carbohydrates. So fewer hydroxyl groups, well, that's really kind of vague when you're looking at a molecule, having to count them out and figure whether it's a carbohydrate because the ratio is 6 to 12 to 1, or just counting out the hydroxyl. A couple things to keep in mind. Lipids are usually sort of long carbon chains with either single and or double bonds involved in them, and they're made up of just the unit you see. Whereas if you think about carbohydrates, we talked about how they're simple sugars, or the basic form of carbohydrates. It's a simple subunit. So remember, carbohydrates are basically just long polymer chains or branched chains of smaller subunits called sugars. Lipids are not made from smaller subunits. When you see a lipid, what you see is the lipid. It's usually long carbon chains with hydrogen and hydroxyl groups on it. So that's how you can visually notice the difference between lipids. And the other main difference between lipids and carbohydrates is that carbohydrates are hydrophilic, so they are water-loving, meaning that they will mix with water. And you know that from dissolving sugar in water. Whereas lipids are hydrophobic. So I'll highlight that here. And if you think about lipid, an example could be oil. When you try to mix oil with water, they don't mix. And that's due to their chemical makeup. So they don't love water, they don't mix with water. Carbohydrates do. Okay, so lipids, the importance of lipids is used for storing energy and building membranes. Those are the big functions of lipids. And lipids can be broken down into smaller subcategories. So remember, try to keep in mind when we're going through these biomolecule notes, we don't want to memorize every little atom that's involved in the makeup of these. We don't want to memorize what long lipid chains look like or what they're properly named. We want to be able to just look and recognize and identify what category of biomolecule it goes into. So this is the purpose of this note, is for me to point out the main distinguishing features between those. So the first category is something called a triglyceride, and tri meaning 3, and the 3 refers to fatty acids. So we have a molecule called glycerol, which looks like this. I believe it's labeled here. Yes, here it is. So glycerol is basically 3 carbons with 3 hydroxyl groups. That's what glycerol is made up of. When it bonds together with 3 fatty acids, so basically a long carbon chain with some hydroxyl groups, and can possibly also have some double bonded oxygens. So remember, these R's, they're just representing that we can have lots of carbons or more subunits attached to make up different types of chains. So they're just general letters they use to represent that more can come off of the side of these chains. So a triglyceride is made up of glycerol plus 3 separate fatty acid chains that actually come in. So this is 1 chain, this is 2 chain, and this is number 3 chain. And they come in and interact with the hydroxyl groups on your glycerol. This is how a triglyceride is formed. Okay, so let's look at that first. Remember from our hydrolysis and condensation reaction review that if we're looking at this reaction in the forward direction, it's a condensation reaction, meaning that we're forming 3 waters. Well, those waters have to come from something. So remember, one of these guys is going to give up on each of these a hydrogen and an oxygen, and the other is going to give up a hydrogen. That gives you your water. And because there's 3 subchains coming in, this is where your 3 waters come from. So all of these come out. And that's where this comes from. And so remember, in a condensation reaction, those atoms are removed, and the remaining two chains will come together. So you can see what's left now forms a bond. Okay, and this might be a new term. Anytime these three atoms are interacting, so a carbon with a double bonded oxygen with another oxygen in between a carbon is called an ester linkage. So this, they've outlined it here, this represents an ester linkage. Carbon double bonded oxygen to another oxygen, single bonded oxygen to another carbon. So our triglyceride term comes from the three fatty acids that came and bound to the three hydroxyl groups on glycerol. Okay, and that's all you need to know for at least in terms of the structural makeup of it. Now remember, like I said, a lot of the lipids, these chains are long chains of carbons, and your textbook actually shows you some examples of those. Now, types. The biggest terms or biggest subcategories of triglycerides is something called saturated versus unsaturated. Now, I just told you that a lot of the lipids that we deal with are longer carbon chains. The main difference between saturated versus unsaturated is saturated means that all your carbon atoms are single bonded. Unsaturated means that you have at least one or more double bonds in those carbons. And this structure here is important because when you have single bonded carbon atoms, they pretty much just line up straight in a linear chain. When you add some double bonds in, what happens is the angles start to change. Remember we talked about bond angles and the shapes of different molecules? If some double bonds are there, it actually causes the molecule to be kinked and it gets bent. And what happens is we call that unsaturated. These are mostly liquids. So when you have single bonded carbons, you have a nice solid structure. These are things like butter. When we have double bonds that are added into the carbons, we get kinks and the shape changes, so the overall structure changes, and we end up with liquids, an example being different types of oils. Okay, second category, something called phospholipids. So lipids, again, are made up of, if you can see, long carbon chains. So long carbon chains, and the only difference in terms of a phospholipid from other types of lipids is this key phosphate head. Okay, and a phosphate head means that, you're going to have a phosphate head. The actual chemical makeup, when you're going to look to identify, is a phosphate with 4 oxygens surrounding it. You might remember this from chemistry. Phosphate has the formula, it's an ion, polyatomic ion. It has this, and it's got an overall charge of 2-. That's a phosphate. This is what the structure of phosphate looks like. And a phospholipid is basically long carbon chain tails, and there's always 2. And it has a phosphate head. And the head is hydrophilic. The tail is hydrophobic. Remember, the lipid part of the structure is not water-loving, but the phosphate end of the structure is. Okay, the last 2 categories of lipids are steroids, and these are consisting of carbon rings, so usually 4 carbon rings linked together. They're naturally produced in the body. You may have heard of steroids before, and they're necessary for growth. Cholesterol is one example of a steroid that's found in our bodies that is needed for cell membrane function, but we can also have bad cholesterol in our body that actually clogs our arteries as well. So we don't need to know much more detail about the steroids or the waxes in terms of their structural makeup or having to identify them. The ones you guys need to know are the 2 that I just went through structurally and outlined those to you. So if I haven't gone through something, there's a reason for it. We need to know that these 2 things fall under the lipids category and maybe be able to describe what they're made up of. But outside of that, that's about all you need to know for those. So waxes, example of waxes, probably the most common thing you might be able to relate to are plants. If you think of a waxy coating on the outside of an apple or a leaf to try and prevent water loss in your green plants, those are different places you're going to find the waxes, and they're usually firm but pliable. So that means they can they have a small bit of movement to them. They're not a rigid structure, and that all has to do with their chemical makeup as well. Okay, so just to sum up, we've dealt with carbohydrates. The way you're going to identify those, they're made up of simple sugars. So you can have monosaccharides, which is just one, disaccharides, which is two, polysaccharides. So remember, carbohydrates, there's different categories where, depending on the number of small subunits you have, make up more complex type carbohydrates. When we get to lipids, lipids are not bound to that ratio that we talked about. So remember, carbohydrates have a 6 carbon to 12 hydrogen to 6 oxygen. Lipids don't have that ratio. So they do contain the same atoms, but they're not bound to that ratio. They can have any number of those, is what makes up lipids. And the two big categories you need to know for lipids are the triglycerides, which is a glycerol coming together with 3 fatty acid chains, and the phospholipid, which is a phosphate head with 2 lipid or fatty acid tails coming off of it. And it's always 2. It's always going to look like this. Okay, and that's it for the lipids.